Welcome to Altabay Solutions Regression for Research Part 1, Data Types for Regression. Before getting into the types of regression models, we must first understand different types of data and how they are measured to know the valid type of regression to use. So, let's go ahead and talk about the following: discrete versus continuous data, different scales of measurement, and a basic intro about regression. Then, we'll talk about data types for common regression models: ordinary least squares linear model, discrete log linear model, ordinal log linear model, multinomial classification model, binary classification model, time series model, and panel data model. First, let's talk about the two types of numeric variables, the discrete and continuous variable. Discrete variables are basically results of counting, which means they are also countable at a certain amount of time. For example, the number of students in a class or the number of leaves on a tree. It may take a long time to count, but it's still technically countable. Now, continuous variables are the results of our actual measurement. It is impossible to count all possible values of a continuous variable. For example, the measured height of a person can be shown as 60 inches, or 60.5 inches, 60.35 inches, 60.335 inches, and so on. As an easy rule to distinguish them, if it is written with decimals, it is more likely to be continuous. Just note that this is not always accurate and you should always double check. After determining the different variable types, we can now go to the different scales of measurement. This is also important, as some regression models are only valid to use when variables are measured at a certain scale. We have nominal, ordinal, interval, and ratio. Let's go over them one by one. First, we have nominal or categorical variables. These are variables without numerical value or order. They are usually represented as names, text, or recoded into numbers. Note that the recorded numbers still do not mean anything numerically. For example, brands of shoes or types of cars are considered nominal variables. Next is the ordinal scale, which include values you can put into order or ranks. It can also be expressed as numbers. For example, a person's rank in an exam can be ordered because we know that the 5th placer is higher than the 8th placer. Or it can also be expressed in categories. Sizes of shirts. Small, medium, and large are not numbers, but we know that large is bigger than small. Moving on, interval scales are variables which basically mean the difference between two ordered values is measurable. For example, a temperature of 90 and 100 degrees Celsius has a difference of 10, which is the same as the difference between 110 and 120 degrees Celsius. Lastly, we have ratio scale, which is almost similar to interval. The only difference is the existence of an absolute zero. For example, in measuring length, 0 inches means there is no measured length. Comparing to the example for interval scale, 0 degrees Celsius does not indicate an absence in temperature. Mathematical operations can now be used for these data types. Integrating what we have so far, discrete variables are usually measured at least in ordinal scale, while continuous variables are usually measured at least in an interval scale. Now let's give a basic definition to regression. Regression analysis is a statistical method commonly used to explain the relationship between a dependent variable and one or more independent variables. It is used in multiple fields and uses multiple data types which give rise to different types of models. We'll have separate videos to discuss its different types in detail, but for the meantime, here are the minimum data types required for each. First, we have the ordinary least squares linear regression, or OLS. It uses a continuous dependent and continuous independent variable, with the exceptions to few categorical variables like dummies. It's the most common and most widely used in multiple fields. For example, understanding the effect of calorie intake and exercise duration on average weight loss in kilograms. Next is the discrete log linear model, which uses discrete dependent and continuous independent variables, still with the same exceptions. It is commonly used on similar problems with OLS, but the dependent variable is discrete in nature. For example, understanding the effect of socioeconomic factors on an individual's ideal number of children. Now we have the ordinal log linear model, this time ordinal dependent with continuous independent variables. Again, commonly used on similar problems with OLS, but the dependent variable is now ordinal in nature. For example, understanding the effect of calorie intake and exercise duration on BMI classification. Moving on, we have the multinomial classification model. This uses a categorical dependent variable with more than two categories and continuous or categorical independent variables. It is commonly used in classifying a subject into one of more than two possible categories. An example is predicting an individual's socioeconomic class based on his spending behavior without knowledge of his monthly income. A simpler form of this model is the binary classification model, which uses a binary dependent and continuous independent variables. It is commonly used in classifying a subject into one of only two possible categories. For example, predicting whether a person applying for a bank loan is fraudulent or not. Next is time series models. This uses a time series data structure for both dependent and independent variables, commonly used in finance, economics, and forecasting problems. An example is financial soundness indicators and its effect on monthly bank revenue. And finally, we have panel data models. Similar structure to a combination of multiple time series data. Also commonly used in finance, economics, and forecasting problems. Here, we can extend the example but across banks in Southeast Asia. We hope you learned something from us today and got a better understanding of different types of data for regression. Subscribe for more, and you can also comment down below if there are topics you want us to cover in our next lectures. Got questions? Want to learn more about statistics? Need help on your thesis? We got you! Just visit our Facebook page or contact us through the following.